Good day, my audience. On the last lesson under systems of linear equation is what we are going to do right now. Previously, we have looked at how to find the rank of the matrices, and then we also looked at how to reduce a matrix to row canonical form. Now, we are going to see how to solve this system of linear equation. First of all, they say we should first of all get the augmented matrix M. If you get the augmented matrix M, then reduce the augmented matrix to echelon form. Secondly, reduce it to row canonical form. From there, find the values of X, Y, and Z. So quickly, we move to work. Okay, what's the augmented matrix? The matrix, let's say that the matrix is 4 minus 5, 6, 8 minus 7, 3. The coefficients of this 4 minus 5, 6, 8 minus 7, 3. Then 7 minus 8 and 9 is a matrix. Now the augmented matrix, which is M, is 4 minus 5, 6, and then 3. We have 8 minus 7, 3, and then 9. We have 7 minus 8, 9, and 6. This is the what? Augmented matrix. Now quickly we go ahead to row reduce it to echelon form. To row reduce this to echelon form, okay, I would like to reduce, okay, we have 4 there. This 4 can counter this 8. We can have a replacement for r root 2. R root 2 is equals to r root 2 minus 2 r root 1. Let's look at that. R root 2 minus 2 r root 1. Let's perform the operation there. R root 2 is 8 minus 7, 3, and 9. And 2 r root 1 is 8. 2 here is minus 10. 2 here is 12. 2 here is 6. Let's take it again. We have 8 minus 7, 3, 9 as our r root 2. Then 2 r root 1 is 8 minus 10, 12, and 6. So when we subtract, let's see what we'll get when we subtract. Let's write it down here. We have 4 minus 5, 6, 3 as r root 1. Then our r root 2 is what we have from there, 0. Minus 7 minus 10 is 3. We have 3 here. And then 3 minus this is minus 9. 9 minus 6 is 3. Is what we have. And then here we have 7 minus 8. We have 9 and we have 6. Now this is a new matrix that we obtained. There was the next step. The next step, I can see that I have 3 minus 9 and 3. If I divide here by 3, I'll be able to eliminate this minus 8. Okay, so let's see what we have there. My M is to first of all put it in echelon form, the upper triangular matrix. So if I divide here, if I have r root 2 divided by 3, will yield r root 2 divided by 3 will yield 4 minus 5, 6, and 3. And we have here 0. 3 divided 3 is 1. 3 divided minus 9 is minus 3. 3 divided 3 is 1. Okay, you have 7 minus 8, 9, and 6. So, quickly, let's solve. This will give us subtracting. I want to make here 0. I have r root 3 is equals to r root 3 plus 8 r root 2. R root 3 plus 8 r root 2. I'm going to perform the operation down here. Arrow 3 is 7 minus 8, 9, 6. And 8 arrow 2 is 0, 8, 20, minus 24, sorry. Minus 24, yeah. And then 8 there is 8. Let's take it again. 8 times this is 0, 8 minus 24 and 8. So let's write down, we have 4 minus 5, 6 and 3 for row 1. Then for row 2 you have 0, 1 minus 3, 1. Then for row 3, add. This plus this is 7. This plus this is gone, you have 0. This plus this. If you remove 9, 24 minus 9 is 15. So we're having minus 15, I guess so. This plus this is minus 15. This plus this is 14. This is what we have as a new matrix. So we are going to make here 0. And also we have to make here 0 as well. So the first thing I'm going to do, because of this one that I've obtained here, it will help me to make there 0. So what do I have? I have arrow 1 is equal to arrow 1 plus 5 arrow 2. Okay, so let's solve this down here. What's our arrow 1? 4 minus 5, 6 and 3. And then 5 arrow 2 is 0, 5. 5 here is minus 15. 5 here is 5. So if I add up, I'm going to have 8. I'm adding now. I have minus 9. If I add there, I have 0 and then 4. Sorry. I have 0 and 4. So this is my what? Arrow 1. So let's quickly write it down here. I'm writing it down here quickly. I have from here, I have the matrices. My arrow 1 is now 4, 0, minus 9, 8. You have 0, 1, minus 3, 1. 7, 0, minus 15, 14. This is what I have. We have not been able to achieve the echelon form yet. So I want to make here 0. Once I make here 0, we have achieved the echelon form. So how do we make that place 0? We take care of this operation. We say arrow 3 is equals to arrow 3 minus 7 over 4 arrow 1. So let's take care of this. Now arrow 3 is what? 7, 0, minus 15, and 14. And 7 over 4 arrow 1. 7 over 4 times 4 is 7 here. Here is 0. Now 7 over 4 times this is plus 63, sorry, over 4. Plus 63 over 4. Am I correct? Yeah. Plus 63 over 4. Then 7 over 4 times this. 7 over 4 times 8. Okay? Will give us 14. 14 will give us 14. If we subtract, right? We are subtracting. Subtract, you have 0, you have 0. Subtract here. Minus 15 minus 63 over 4. You have minus 6. Come on. Okay, let's take it again. you have, here is arrow 3. Arrow 3 is 7, 0 minus 15, 4. Then 7 over 4 arrow 1 will give us, if you multiply here, you have 7. Multiply here. If you multiply here, supposed to be minus here now. Minus should be here. Sorry. Minus is meant to be there, so that here is plus. Okay, plus 63. That's a mistake. Because if you multiply here by 7 over 4, you'll be having minus 63 over 4. If you multiply here by 7 over 4, you have 14. So when you subtract minus 15 minus 63 over 4, it will give you minus 15 plus 63 over 4. And when you round up, that will give you 3 over what? 4. So here is 3 over 4. This minus this is 0. So the new matrix, I'm cleaning here. So I can have the new matrix is 4, 0, minus 9, 8. The second row is 0, 1, minus 3, 1. And then the third row is what we have here, 0, 0, 3 over 4, and then 0. Okay? Now, we have here, this is the echelon form. Echelon form. This is a what? Echelon form. So what we need to do to make it row canonical form, we need to make here 1. Here is already 1. We make here 1. And then all the numbers on top of this 1 becomes 0. Everything apart from these pivots are going to be 0. The pivots are going to become 1. So if we divide through here, first of all, let me divide here. Arrow 3. Arrow 3 divided by, times 4 over 3. 4 over 3 arrow 3 will give us 4, 0, minus 9, 8. 0, 1, minus 3, 1. 0, 0, 1, 0. When you multiply here by 4 over 3, you have 1. So this is what we have. Now, I'm going to use this 1 now to eliminate this and this, make them 0. So we're going to perform these two operations. Arrow 1 is equals to arrow 1 plus 9 arrow 3. We're also going to perform the operation arrow 2 is equals to arrow 2 plus 3 arrow 3. These are the two operations. I'll perform them and then I'll write down the matrix. Now the first one, let's find arrow 1. Arrow 1 is 4, 0, minus 9, 8. And 9 arrow 3 is 0, 0, 9 is here, and you have 0. Which will give us, you are adding 4 is here. That is for arrow 1. 4 is there. Okay. You have, okay, 4 is there. You have 0 here. You have 0 here. And you have 8. Okay. That is 4. This is arrow. This will replace arrow 1. Then which one will replace arrow 2? Our arrow 2 is 0, 1, minus 3 and 1. Then 3 arrow 3 is 0, okay, 0, 3, and 0. When you subtract, you have 0. Sorry, you have 1. So when you add, you have 0, 1, 0. So the new matrix, becomes from here. This was the last matrix. So if we replace our arrow 1 by this and replace our arrow 2 by this, we are going to have 4, 0, 0, 8, this one replacing arrow 1, then that one replacing arrow 2, we have 0, 1, 0, and 1. And then finally, our arrow 3 is already there, 0, 0, 1, 0. Now, what is left is for us to make here 1. That's all. And then we have solved the system. Remember that if we remove this, this is the this part of the metric, this part of the system, whereas this other coefficient belongs to this part of the system. So I'm going to divide arrow 1. If I divide arrow 1 divided by 4, it will give me the matrix, the augmented matrix, 1 here, 0, 0. 8 divided by 4 is 2. Write down 0, 1, 0, then you have 1. Here you have 0, 0, 1, and here you have what? 0. So what does this entail? This is the row. This is the row canonical form. We have reduced this. We have reduced this matrix to row canonical form. Why? Because under the leading one here, we have zeros. Apart from the leading one here, the other elements are zeros. Since we have put it in row canonical form, from the last column, we have x is equal to 2. X is equal to 2. Write it boldly. S is equal to 2. We also have y is equal to 1, and z is equal to 0. Okay? And z is equal to 0. So the system of the linear equation 4x minus 5z plus 6z plus 3 etc. can be solved using the row canonical form, and the solution is s is equal to 2, y is equal to 1, and z is equal to